Construction of a tangent to a circle.
Construction of a tangent to the circle. The next construction we are going to study is to construct a tangent to the given circle. Before we start with the procedure of constructing a tangent, we will recapitulate what we have learned about the tangents of the circle. In the figure here, you see that the line L intersects the circle in one and only one point. The line L is the tangent to the circle at point A. Also, we have learnt that a tangent to a circle is perpendicular to the radius at the point of contact. We will use this property to construct a tangent to the circle from a point given on the circle. Let us learn now to construct a tangent to a circle at a point on the circle. See the example here. Draw a circle of a radius 2.6 centimeter. Draw a tangent to that circle using the center of the circle from any point on the circle. The first step of our construction is draw a circle with center O and radius 2.6 centimeter. Step 2. Take any point P on the circle and draw ray OP. Step 3. Draw the line L perpendicular to ray OP at the point P. Line L is the required tangent to the circle at point P. We learned to construct a tangent to the circle using the center of the circle at a given point. Can we draw a tangent to a circle at a point on it without using the center? To do so, we will have to recall the property of angles in alternate segments. If a line is drawn through an end point of a chord of a circle and an angle formed by it with the chord is equal to the angle subtended by the chord in the corresponding alternate segment, then the line is a tangent to the circle. We shall use this property to construct a tangent to the circle without using the center. In the figure here, PQ is the chord and point R is a point on the circle other than points P and Q. Join RQ and RP. If line PM is the tangent of the circle at point P, then by tangent secant theorem, angle QRP is congruent to angle QPM. Conversely, taking QP as one side and P as the vertex, if we draw angle QPM such that angle QPM is congruent to angle QRP, then the line PM must be a tangent to the circle. From this, we can draw inference that if we construct the congruent angles, we will be able to get a tangent. Now let us construct a tangent without using the center of the circle. Example. Draw a circle having radius 3 centimeter. Draw a chord XY equal to 5 centimeter. Draw tangents at points X and Y without using the center. Construction. Step 1. Draw a circle with radius 3 centimeter. Draw a chord XY of length 5 centimeter. Now, we have to construct tangents at points x and y. Let us construct the tangent at point y first. Step 2. Take any point M on the circle other than points x and y. Joining xm and ym, angle XMY is formed. Now, we have to construct an angle which is equal to angle XMY. So step 3. Taking XY as one side and point Y as vertex, draw ray YN making an angle equal to angle XMY. The line containing ray YN is the required tangent. To draw the tangent at point X, we will follow the similar procedure. Here, construct an angle equal to angle XMY at point X as vertex and chord XY as one side. Draw ray XP such that angle YXP is equal to angle XMY. The line containing ray XP is the required tangent. Here is one activity. We have to construct a tangent to the circle which is drawn with the help of a bangle. So here, we don't know the center of the circle. Hence, we will follow the method of constructing a tangent to the circle without using the center. In this method, we make use of the property of equal angles in corresponding alternate segments. First, draw the circle with the help of a bangle. Draw chord AB of the circle. Take any point C on the circle other than points A and B. Join AC and BC. Construct an angle congruent to angle ACB, taking point B as vertex and chord AB as one side. The line containing ray BM is the required tangent. To draw tangents to a circle from a point outside the circle. Suppose a point lies outside the circle. How many tangents can you draw? We can draw 2 tangents from a point outside the circle. We have drawn tangent to a circle at a point on the circle. Which property did we use there? A tangent is perpendicular to the radius at its outer end. Can we use the same property to construct the tangents from a point outside the circle? Look at the figure here. Here, you can see 2 right angles. So, we will have to draw 2 right-angled triangles to get the required tangents. We know that the angle subtended by a diameter is a right angle. To construct the tangents, we need 2 right angles. So, by taking OP as diameter, we can draw 2 right angles, angle OAP and angle OBP, as you can see in the figure. We will draw tangents to a circle from a point outside the circle. Example. Draw a tangent to a circle with radius 3.6 centimeter and center C. Point B is at a distance 7.2 centimeter from the center. Since point B lies outside the circle, we know there will be two tangents to a circle from this point. Let us see the steps of construction. Step 1. Draw a circle with center C and radius 3.6 centimeter. Take point B such that CB is equal to 7.2 centimeter. Now, we have to find the midpoint of segment CB. You know, to get the midpoint of a segment, we have to construct a perpendicular bisector. So, our step 2 is obtain midpoint M of the segment CB. Draw a circle with center M and radius MB. Now, we will label the points of intersection. Step 3. Let the points of intersection be P and Q. Draw lines BP and BQ, which are the required tangents.
Draw a tangent at any point M on the circle of radius 2.9 centimeters and center O. Steps for construction. Draw a circle with center O and radius 2.9 centimeters. Take any point M on the circle. Draw ray OM. Draw a line L perpendicular to the ray OM at M. Line L is the required tangent to the circle. Draw a circle with center P and radius 3.1 centimeters. Draw a chord MN of length 3.8 centimeters. Draw tangent to the circle through points M and N. Steps for construction. Draw a circle with center P and radius 3.1 centimeters. Draw a chord MN of length 3.8 centimeters. Draw a ray PM and ray PN. Draw a line L perpendicular to ray PM at M. Draw a line M perpendicular to ray PN at N. Line L and line M are tangents to the circle through points M and N respectively. Draw Draw a circle of radius 3.5 centimeters. Take any point K on it. Draw a tangent to the circle at K without using the center of the circle. Steps for construction. Draw a circle with center O and radius 3.5 centimeters. Take any points K and A on it. Draw a chord AK. Take any point B on the circle in the major arc other than A and K. Join AB and BK. Using K as vertex and AK as one side, draw ray KP, making an angle equal to angle ABK. The line containing ray PK is the tangent to the circle at point K. Draw a tangent to the circle with center O and radius 3.3 centimeters from a point A such that distance of OA is equal to 7.5 centimeters. Measure the lengths of the tangent segments. Steps for construction. Draw a circle with center O and radius 3.3 centimeters. Draw a point A 7.5 centimeters away from point O. Produce ray OA. Draw perpendicular bisector of segment OA. The bisector intersects OA at point M. Draw arcs with radius MA and center M on the circle. Name the points of intersection B and C. Draw lines BA and CA. BA and CA are required tangents. On measuring the tangent segments, we find AB and AC are approximately 6.7 centimeters.